These problems today are going to involve multiplication. So yeah, more stuff just like yesterday, but just new properties. So we're just going to get right into it once again. So 6.2 is all about multiplication properties of exponents. I believe we're going to learn 3 properties today, in addition to the ones that we learned yesterday. So let's get to it. Simplifying exponential expressions. This is how to know if your exponential expression is completely simplified. This is a lengthy list. And remember, these notes are online. So if you don't feel like copying them all down, that's okay. But I would recommend shortening these a little bit. So say something like no negative exponents. The same base does not appear more than once, right? No powers are raised to powers. No products are raised to powers. I'll maybe show you guys an example of this, of each one of these. Right, so negative exponents, if we had like x to the negative third power, that's bad. Another thing that's bad is I can't have like x to the third and x to the second. See how I have the same base twice? Right? That would be bad. That's not simplified. A power raised to a power, that would be like x to the third power squared. You can't have an exponent to another exponent, right? And it says no products are raised to powers. So if you have something like x times y to the third power, that's also bad, right? We're going to learn how to, over the next 2 days, simplify all of these bad examples that I'm giving you, right? And then it says no quotients are raised to powers. So a quotient is like division or a fraction, right? What do you guys think we would have to do with this 3? I'm going to zoom in a little bit more. What do you think we'd have to do with this 3 here? What do you usually do with parentheses and there's a number on the outside, Brant?
Do x to the third over y.
Beautiful. You're going to have to distribute that exponent. And that's one of the properties we're going to be learning today and tomorrow. So we're going to do the same thing up here. We'd have to distribute that 3, right? Anyway, so numerical coefficients and a quotient do not have any common factor other than 1. This is basically just saying reduce your fraction. So like on the homework where you had -3 over -6, you have to reduce that, right? Okay. So once you see all of these properties, eventually when you look at a problem, you're going to see how much you're going to have to do. And it's just going to take some practice, okay? So today we're going to get into how to simplify anything with multiplication in it, any problem with some sort of multiplication property in it. All of these non-examples are good ones to talk about because here, do you see how I have 2 of the same base? That's bad. It's also bad because I have a negative exponent, right? So that's also bad. Here I have 2 of the same base. That's bad. Power of a power. Can't have an exponent to another exponent. That's bad. Here's that product, that quotient. And then here, once again, reduce your fraction, right? So this is like the first one, the second one, the third one, the fourth one, the fifth one, the sixth one, right? That's a non-example of all 6. All 6 of those non-examples are not simplified, right? And I gave you examples of a lot of these, right? So you don't need to write them down again if you don't want. But remember, these slides are online. These notes are going to be posted online. So if you want to go back and check them out, you can. If you are looking at products of powers with the same base, they can be found as writing each power as a repeated multiplication, right? If we have 3 to the 5th power, that means we have 1, 2, 3, 4, 5 3s, right? And then if we have a 3 squared, that means that we have 2 3s, right? So how many total 3s do we have? 7, right? Do you see how that 5 and the 2 make 7, right? So your multiplication property of exponents, the very first one is talking about product of powers, which we're going to get to and formalize right here. So the product of powers property, so I would call this product of powers, and I would write this down. Whenever you have the product of two items with the same base, two exponential expressions with the same base, you can add their exponents and put them together, right? Ooh. It's like an explosion of coffee. Okay. Questions on that? Okay, we're going to cruise through a few examples here. This first one, 3 squared times 3 to the 5th power should be 3 to the 7th. What about B? So I have 2 to the 4th power. What's my like term? Same base, right? So if we're looking at base 2, how many 2's do I have? 4 plus negative 2 gives me 2, right? Right? I'm doing 4 plus negative 2. And then for my 3 to the 4th and 3 squared, I have a total of 6 3's. Right? These numbers are going to be ginormous, so I'm not going to actually expand them. We'll just leave it like it is, right? Let's try question G and then question H. For G, first thing I would do, I have like terms, I need to combine them. How many total m's do I have? Show me on your hands. I have 5, right? Even though this m doesn't have an exponent, it really has an imaginary 1, right? So I have 5 m's and then n to the negative 4th power. I don't think I'm done because I'm breaking another rule. Brant, what do I do?
Put the negative n underneath.
Beautiful. Nancy's got a negative attitude. We're going to move her to the basement so she can change that attitude. And then we're done. All right. I like H just because it involves a lot of x's. I actually have 4 like terms here. So if I have 1, if I'm going to add all these exponents, right? That would be 1 plus negative 1 plus negative 3 plus negative 4. So how many x's do I have?
1.
I have technically x to the negative 7, right? And I have to simplify that because Xavier's got a bad attitude. So I'd have to write this as 1 over x to the 7th. So hopefully you're seeing how yesterday's stuff plays into today's stuff, right? We're going to have to practice negative exponents still. We're still going to have to practice some 0 exponent stuff. But we are throwing in this new idea of combining like bases. Another thing that we're going to be doing today is power of a power. So you don't need to write this down. We'll go over the actual property in a second. But if I have 4 cubed squared, this technically means I have 2 of these things, right? So I'm going to have 2 4 cubes. And if I expand those 4 cubes, I have a total of 6 4's, right? So what did I do with the 3 and the 2? I multiplied them. So the formalized property here, we're going to turn the page. This is called a power of a power. So that means like a double exponent. When you have a power raised to another power, you're going to multiply those exponents, right? And if you want, you can always expand these, but sometimes, like you see in this example, when you expand your 6 to the 7th to the 4th power, if you were to actually expand that out, that would take you a very long time to count how many 6s you have, right? So that's why we have these algebraic rules to do some shortcuts and stuff. Okay. So like I said, all you need to do is write what I wrote in the boxes. And let's move forward. Let's do a few of these. 5 squared to the 4th power should give me 5 to the 8th. Good. 2 times 4 is 8. I'm a little concerned if some of you aren't multiplying that in the morning. Maybe we need some extra coffee. Okay. 4 to the 3rd power to the 0th power. Why is that? Beautiful. Anything with the 0 exponent is 1. So if we're looking at question B here, 6 to the 0th power is 1. What's 1 cubed? Yeah, 1 times 1 times 1. Isn't that just 1? So there's a couple different ways you can solve this. You could solve the parentheses first and then apply the exponent. Or here, you could do what's 0 times 3? Well, 0, so 6 to the 0th power is also 1. Do you guys see how we could solve that 2 different ways using different properties? Okay, I like question C. Let's go over this one together. Actually, let's do this C, capital C. First things first, I see a power to another power, so I have to multiply those exponents, right, to get x to the negative 15th power. Do you see how I have 2 of the same base? I need to combine those together, right? So I have to add my exponents. Negative 15 plus 4 gives me negative 9. And then I still have another step to do, right? This guy got a bad attitude. Got to move it to the basement. So my answer should be 1 over x to the 9th. Did I do something wrong? Oh.
The 9 should be in the 11.
Oh man, you guys, I saw like 4 hands up. I'll get you guys in a minute. That should be an 11. Adding is hard sometimes, you know? For some reason, I always mess that up. Weird. Okay. Any questions on this question other than apparently your teacher can't add at 8:30 in the morning? Okay. Last thing we need to talk about is a power of products, and this is what Brant was talking about. We're just going to skip right to the power of a product. It's this idea of distributing the n to both terms. Do you see how if you have a product in the parentheses, you're going to sort of distribute the exponent? Right? So if you have A and B in the parentheses and there's an n on the outside, that means both things in the parentheses need that exponent. If you look at this first example, I have 2 things in the parentheses. I have the 2 and I have the y. That negative out front stays out front, and then I get a 2 squared and a y squared. Well, I can simplify 2 squared. 2 squared is 4. And then I have my y squared, right? That's different than question B. So if I have a negative 2 to the 3rd and a y to the 3rd, you see how it's different when the negative's out front versus in the parentheses? Negative 2 times negative 2 times negative 2 is a negative 8, y to the 3rd. But what I really want to get into is question C here. when you distribute this exponent, you've got to multiply, right?